Find the mass of the Earth with the radius of Earth being 6.38 times 10 to the 6 meters. We will use a 10 kilogram mass in our solution. That's a little bit later, but the other mass will be that of the Earth. So that's a little bit more, like a little further down the line. So this one's kind of interesting.
We'll look at number 2, right? Oh, wait.
The weird part with this one is that I don't have another. Looking at this has us relating F to mg. But if I just do so let's rearrange this. Mass of the Earth. And then it's kind of weird because I have an F. So we're looking for the mass of the Earth, right? Mm-hmm. But then it's kind of funky because I still have to say F equals. Right. So it's kind of weird. Like, how do I know what that force is? What do I do with that? Well, before we even, now that we see that, we have that force in there, but I don't really have anything telling me what to do with that, I can make a relation. So I can say, okay, F equals MA, right? Which we know is the same thing as G. Times G. Alright. So and then I can relate it. Since I know F equals MA, F equals MA, F equals MA. Like a lot of times we want to start with F equals MA. So and then little m, big M, and R squared. So now that I have this relation, now I can do a little bit of an easier manipulation. So now I can say big M, mass of the Earth, equals, so we got R squared on the bottom, which will move to the top. We got big G. So now, like, we're about to do it now. We got M and M1. But I have a, let's see. And then G will be on top. So here's the big M I'm trying to solve for. So I want to put everything on the other side. Let's do it. Let's do it again.
I don't really understand that part.
So I want to solve for the mass of the Earth. I want to solve for big M. Because it's like one mass,
So, yeah, so that's
one
what
body,
we
and
want.
mass
We
of
want
another
the
body.
big M. That's what we're looking for.
Yeah.
Right?
So here's the mass of the Earth.
So you have to multiply R
Alright.
squared.
Squared. So R squared. So I'll go ahead and start writing it up. mg times R squared. So and then multiply by R squared. And then I have to divide by G, right? Because that's being multiplied. So divided by big G. So that those can cancel out. So divided by big G. So that's the big G.
Again.
And then I gotta get this away from this.
So what to do about that?
Divided by that. So I can get rid of that. Alright, cool. Oh, one more. Did I put it? Oh yeah, I already put that there. Alright, so now I'm left with big M. Good. So now the M, I got two M's right here. So two little M's. So now I can cancel that out. So that's how we get rid of me needing another mass. So now we can do all this. So now putting in my, I'll put it over here so I can write it bigger. M equals 9.8 squared times R squared. So my R, 6.38 times 10 to the 6 meters. All over big G. 6.674 times 10 to the negative 11. All that jazz. All that jazz. So, see if I want to write in scientific notation. Oh, that's why. I knew there was something. Keep on forgetting to square this. I knew there was something wrong with that. Keep on forgetting to square that. So, because these, I knew I forgot the square because 7 divided by negative 11 didn't equal. Well, we'll see. We'll see what it looks like. Let's square it. Times 10 to the negative 11. So let's see what if our
I got a question. How did you put the first part of the calculator? Why did not get 62
let's see here, 9.8 times 6.38 times 10 to the 6. Yeah.
Am I not supposed to square it?
Not for the. Oh, this is squared. Golly, I squared the wrong thing. sorry about that. Let's see, 6 point. .38 times 10 to the 6 squared. 4.07 times 10 to the 13. And times 9.8. Yeah. All right.
Okay, so how did you get, 3.99?
Yeah, so 6.38 times 10 to the 6 squared. You're right. The radius, g times radius squared. So radius squared. 6.38 times 10 to the 6 squared. I got 4.07 times 10 to the 13.
I'm not going
And then times that 9.8.
to. I get that part. I don't get this part right here.
Yeah, we did that because
I just need like the canceling part.
let me see what happens if I put in. Well, it's because of the F.
All right.
Like, we don't know if we just moved, if we just solved for mass of the Earth, and then we still had the F, what would we put in for the F? So that's the big question. What would that value be? You know, we don't have a force that they're really explaining to us. So that's why we put it as mg. MA. F, we know F equals MA. That's why we had to solve for
What was that question, Josh?
F. Like, why did we cancel out all this stuff over here? Like, why did we do all that?
Oh, so we could solve for ME?
Yeah, but the big problem is we have this F. Like, what are we supposed to do with this big F? We just have this big force and no value attached
I
to
thought
it.
F was equal to MG.
Right. So we want to relate the MA or MG. We want to relate MG to the other side of the equation because we know what gravity is. Since we know what gravity is, we know that we can keep that in there.
Okay.
Get it?
Okay. Okay.
So then we already did that. So I got that on the
Okay, I have a
top.
question, because you have 3.99 to the 10 to the 14, but will it be the same thing if I have 10 to the 15? 3.9, 10 to the 15, that's the same thing? Times 10 to the 15, that's the answer that I have.
Technically, that would be incorrect.
Yeah, because that's gonna be another.
Yeah, that's a whole nother. That's like going from
So it's not right?
1,000 to 10,000. That's a big jump.
See, look, let's do this over again. We got r squared, 6.38 times 10 to the 6. 6.38 times 10 to the 6 squared. I get 4.07 times 10 to the 13. I do 6.38 times 10 to the 6 squared. Did you get that one?
I got that, yeah.
Alright, so and then we multiply by 9.8.
Alright, well, I got that. I'm just gonna do it that way. I put everything in it. That's what I be doing. I be putting everything in at one time. I gotta break it down.
Maybe
It's easier to break it down.
you might have squared. It might.
I think I squared 9.8.
That's what I'm thinking.
Oh, yeah,
It might have squared all of them.
Okay.
Only square would be 6.3.
So only square at the end of the equation?
Only square the
I would-
constant,
Yeah.
the gravitational constant.
I would one thing I would suggest if you do put it in at the same time, I would probably do a parenthesis. To say that this square.
Yeah, I did that. I think I messed up where I squared the gravity. That's what I
Oh, yeah.
Yeah. If I didn't put an extra parenthesis. Times 2 to the 6. And I square that. Yeah, so it might, yeah.
Thank you.
Here it is. Alright, so now the units. We got meters per second squared. We got a meter squared. And all of this is over there. Unit meter squared over kg squared. Which to make it look easier, let's do meter per second squared times meter squared. Let's do the inverse. Kg squared. Meter squared. So I can see that so I can see it all in one line. I got meter squared, cancel out with meter squared. That's it. So here's where your question will come up. Because we have, these are the units that I'm left with.
Mm-hmm.
Yeah, I was confused.
So now,
And I ended up breaking the newtons down. But I don't know. Back.
a Newton is a kg m over s squared. So now the kg ms squared, well that's Newton, and then m over s squared. These are gonna cross out, and then this is gonna cross out.
So you gonna just go back to kilogram?
Yep. Cool. So we did it right. We got a kilograms for our mass, which is definitely what we wanted. Looks like we'll have to spend more time on 7 next class. What else? So I wanted to go over that because we didn't really talk about that too much, and I was looking back at some of the assignments, and I was like, oh, we didn't get to that point. What is the mass of the Earth? Yeah, so we're pretty close. At least we have that has the current best estimate. But we did everything right for what our data had. 5 times 10 to the 24. So I wonder why. We're a little off. 1.4. Maybe what's the radius? So maybe that's where some of the difference is, because they gave us the approximated value.